Hello everyone. Today we're going to be talking about fractals. Um, Fractals may at first glance seem very much more like art than math, but there is a lot of mathematics that goes behind fractals, and they're really important because they actually tend to show up in nature and the universe quite a bit. Things like this succulent has a fractal sort of pattern to it. Coastlines often are also pretty fractal. And even like this leaf here is fractal. And we can see that because the big shape of the leaf is kind of mirrored in the smaller pieces of it, which is kind of mirrored in each smaller piece yet again. And so fractalness is this idea of little pieces resemble the big whole. And so there's this like self-similarity that happens at different scales. So we're going to be exploring that in these activities. So the first thing that we'll be doing with fractals is we're going to be drawing a snowflake by sort of drawing repeated triangles. So the way this works is you're going to start with an equilateral triangle, or at least as equilateral as you can get it. And then on each surface, on each face, you're going to draw a bump. So there's a face here, so I'll draw a bump like that. About 1/3 this way, and then you do the bump, and then another third. So just split it into thirds, draw a bump. So here's another surface, I'll split it into about thirds, and then I'll draw another bump, and then same thing over here. Another bump. All right, so we've done, I think one iteration was the triangle, the second iteration are these bumps. Now the third iteration is every time you see a flat surface, add another bump to it. So here's a flat surface, so it's going to get chopped into thirds and put a bump on the middle third. Here's another surface, so you do the same thing to that, chop it into thirds, put another bump, and so on, so forth. And you'll just keep doing this until you get a nice snowflake. This is a nice activity because it really does illustrate that like we're doing the same thing just at different scales, and like that is really what is core to fractals. Now once you've finished your snowflake, we're going to move on to a more group activity, and it's going to involve making fractals with these squares. So when your team, or sorry, not your team, but each individual student will pick a rule that they like, and everyone's going to get a square. Now, let's say I've got my square here, and I want to pick rule J. So I got my square, I need to divide it. First I need to divide it into fourths, nice clear lines, and then I'm going to draw it according to my rule. I'm going to color it in according to my rule. I'm going to use rule J, so when I color this in, I'm going to color this square right here. Just like that. And when I'm done coloring this square, I would pass it off to the teammate next to me. So I, as the student, would pass it to the next student next to me. And then I have to figure out what rule did my teammate use, and then use that on all the empty squares. So now let's say that I've gotten past this drawing, and now I have to fill it in again. Well, I'm looking at it, I can match it up with the rule J because we've colored in just that lower right square. Now on every blank square, what I'll do is I'm going to split every blank square into fourths. So that one's split into fourths. That one's split into fourths. And this one too. And then in each of these, I'm going to apply the rule that I figured out had been applied last time. So again, I'm just going to color the bottom right squares of all of these. So this one gets colored right here. This one gets colored right here. And this one too. And then this drawing will get passed to the next student. The next student has to figure out which rule is applied and then again apply that same rule. And if we do that, I think it's going to look something like this. Just like that. So this is 3 iterations. So you can see that these drawings are rapidly getting more complicated, but again, we're doing the same thing. We're applying the same rule just on different scales, smaller and smaller scales in this case. And in the next activity, you'll be looking at maybe some more complicated patterns And you'll also be counting like the area that's shaded in these. So there's some deeper mathematics that we can really discover with these fractals.